we're firing a 20-pound steel projectile at a trash can full of dirt at about 70, 80 miles an hour. How can that not be fun? Hello, I am Alex Noble. I am a mechanical engineering senior here at Andrews University, and for my project, I designed and built an air cannon to test concrete barriers. Unlike some of the other projects, ours was a little bit more vague. It was never presented originally with like an air launcher. It was just, we want to test these new concrete barriers, figure out a way to do it.
My name is Gunnar Løviden. I am the chair of the School of Engineering and also the teacher for the senior design sequence. And an inventor came to Industry Lab and with an idea for a new highway safety barrier. And his idea was that if you built the barrier out of small hard rocks and you hold them together just as loose as possible, when something hits the barrier, instead of the barrier moving, it would shoot out rocks at the back, like the Newton's cradle. And he had done some rudimentary tests at home, but had no way to really verify how well does it work. So we had a group of students design a test system that would be able to sort of assess how well does it work on a scaled down version.
So we went through a couple of different design iterations, trying to use maybe like gravity to power it, using pulleys, a bunch of stuff, and a lot of it was too many moving parts, really complex, and I think it was Dr. Gunnar who was like, hey, what if we tried something with compressed air, something air power? And so we looked into that. We kind of ended up with this air cannon design.
If they can't get traction, we step in and help as necessary to get traction. We don't want them to be totally lost. We don't mind them wrestling with the problem, but at some point we're like, okay, how about this, how about this, how about this?
So hello, my name is Matias Soto. I'm the Director of Innovation and Entrepreneurship here at Andrews University. So the students are giving that statement of work document, and in that document there's a list of requirements. And those are engineering requirements, right? So we try to be as specific as possible in those requirements and say, your prototype, your solution shall do this, right? Shall impact a sample at 70 miles per hour, for example, right? So that's all they're given. And they're being given this framework with these requirements, and then they have to translate those requirements into an actual design.
You think of an air cannon, you kind of have a pretty good idea of what it's going to look like in your mind, but we had to run through like all of our requirements for our project. Anyone could throw together maybe a valve and a way to open that valve, but finding out like, okay, what force is required to open this valve? How fast does this valve need to be open? And optimizing that beforehand so that you know once you build it, you've built it in the best way you possibly can.
We had to design something that actually wouldn't be so big it couldn't be built, but at the same time not so small so the air pressures got very high. Especially one of the students, he just took over and he owned the project. And once he thought it was ready, we actually brought it home to my garden, we pressurized it, and we launched an 18-pound piece of steel, and we launched it at 80 miles an hour. He was booking it.
We tested it at low pressure a couple of times, and man, I was nervous. I mean, I had every reason to believe that it would work just fine. I had spent a lot of time making sure it would work just fine, but I was still so nervous. But after getting it going a couple of times and going, okay, this is working, it was very nice, very, very happy to be sitting there with the finished product. As for skills, I don't see myself building another cannon. But I think the skills I've learned of like, I mean, even just like, hey, here's a problem, here's your constraints, solve it, is just and learning how to be comfortable in that environment and how to like thrive in that kind of environment. I think that's how like a lot of engineering projects would go. I think the skills I've learned to be able to do that are very valuable, and I'll be taking those with me.
The problem required their creativity to find a solution that was not necessarily something they were given. And I think that problem-solving experience is probably the best thing that they're taking out of this senior design experience.
Yes, I think back to when I was in school many, many years ago, and I did my own senior design project, and I didn't have much guidance. And I picked the project, but the most positive thing I can say was that it sucked. As a result, I wasn't really sure if I was a good engineer. So when I see a student that actually gets to do a good project, put a lot of effort in, and it works, and I see them afterwards and they know they did a good job, and you affirm them that they did a good job, they almost like they walk with their back a little straighter. They can approach a job interview with more confidence because they know that they did something and they did it well.
Doing this senior design project is definitely one of the highlights of my engineering degree here at Andrews. I did an internship last summer, and that was something I very much enjoyed. And then coming and doing this project, which was, especially this year, structured to be very, I think they were very intentional about trying to make it feel like a professional engineering workplace, and try to kind of get us some experience in a workplace without actually us being in a workplace quite yet. That and having our professors here be very, very hands-on with our projects and interested and invested with our projects. I think those two things were very, very valuable to me working on this project. And yeah.